Hi folks, let's solve maximum number of events that can be attended to. It's actually a hard problem. So we are given an array of events. The event has a start date and an end date and a value. And we can choose at most k events and they cannot be overlapped. It asks us to give the maximum value we can get. So there are some examples. In the first example, we can attend event 0 and event 1, so we can get 7. In the second event, we can attend event 2, so we can get 10. In the third example, since k is 3, so we can attend 3 events, event 1, 2, and 3, and we can get 9. So some constraints. The start date and end date can be pretty large. So if we do DP, the dimension cannot be the absolute value of start date or end date. The value should be the index. So we can use dynamic programming here. First, we can sort events by end date. And we have dpij. dpij means the maximum value I can get when attending at most j events with previous I events. So I can choose the previous I events, and I can choose at most j events. Then dp event length k is the final answer here. Okay, let's take a look at example and its implementation. So we have 3 events here. 4 is the value of the first event. 3 is the value of the second event. 1 is the value of the last event. Okay, so first we need to sort it by the end date. It becomes this. And the event 2, event 1, the name is not that meaningful. We can reverse them. Yeah. Okay, now we can initialize our 2-dimensional DP array. And we add 1 dimension, and it's very convenient when coding. So the first row and the first column is always 0. Okay, now let's take a look at this for loop. First, we for loop every new event. In the outer for loop, we have an inner for loop. The first inner for loop is used to calculate the non-overlap index. For example, if I is 3, the count event is this event, event 2. And for this event, we for loop every element before it, and we find the closest event that is not overlapped with the count event. So if it's event 2, the non-overlap index will be 1, which means it's event 0. Note, the index starts from 1. So for event 2, the closest non-overlap event is the event 0. For event 0 and event 1, there is no non-overlap events before. So the non-overlap index will be 0 here. Okay, so what's the value of dp11? We know for dpij, if we use I, which means I attended event I, so the value should plus events I minus 1, 2. This is the value of the current event. And what's the previous DP state we can come from? So it's DP non-overlap index, then j minus 1, since we already use 1 event here. So for the current event, if I don't use it, then the previous state is DP I minus 1 j. So for DP11, the value is 4 here. Then for DP12, the value is also 4 here. Okay, now what's the value of DP21? We can do the same. The non-overlap index is still 0. Okay, for DP22 is the same. Okay, 1 is 3, the non-overlap index is 1, and DP31 is 4. But DP32, we know DP32 can become 4 plus 3, and let's say, so DP32 can be DP11 plus event 22, so it will become 7. Okay, so this is for implementation. First, we sort the events by the end date. Then we initialize our 2-dimensional DP array. Then we have outer for loop, which iterates every new events. For every new event, we calculate the non-overlap index. Okay, then we for loop j from 1 to k, we calculate dpij here. So what's the time complexity? In the sorting, it's n log n. N is the length of the event. Then for this outer for loop, we for loop n times. In this inner for loop, first we use linear search to find this non-overlap index, so it's O(n). Then we also has an inner for loop which iterates k times plus O(n)k. So this is time complexity. Actually, we can improve it a little bit. Since we are using linear search to find the non-overlap index, we can also use binary search here. So it will become O log n if we use binary search to find non-overlap index. And we can improve the time complexity to O(n log n plus O(n)k. Okay, that's it. So it's actually a not easy problem. And there are some tricks. We need to sort it by the end day, and we need to have a two-dimensional DP array. And the two-dimensional is based on the index, not the absolute value of the day. Also, it's enough to just compare by end date. We don't need to do that. If end date is same, we sort by start date. It's not necessary. Assuming we have two events. One start date is 3, end date 5. One start date is 1, end date 5. It doesn't matter who comes first, since the latter one will always include the state of the previous one. Yeah, thanks so much.